Welcome back to my channel, Trash to Teach.
If you've ever typed best way to run Linux on Windows into a search bar, you've hit the same wall I did. 3 answers. 3 totally different technologies. And about 100 blog posts that just list features without telling you which one actually fits your situation. WSL2, Hyper-V, VirtualBox. They all let you run another operating system on your Windows machine. That's basically where the similarities end. One of them is a lightweight compatibility layer. One is a bare metal hypervisor baked into Windows itself. One is a full desktop virtualization app you install like any other program. By the end of this video, you're going to know exactly which one to reach for. Whether you're a developer who just wants a Linux shell, someone testing software across multiple OS versions, or someone trying to run an isolated sandboxed environment for privacy or security reasons. Let's get into it. Before comparing them, you need to understand what layer of the system each one lives on. This is the part most comparison videos skip, and it's the part that explains literally every difference you'll see later. VirtualBox is what's called a Type 2 hypervisor. That means it runs as an application on top of your existing operating system. Windows boots normally, then VirtualBox starts as a regular program, and inside that program, it emulates an entire virtual computer, virtual CPU, virtual RAM, virtual disk controller, virtual network card. The guest operating system has no idea it's not running on real hardware. Hyper-V is a Type 1 hypervisor, also called a bare metal hypervisor. This is a fundamentally different architecture. When Hyper-V is enabled, it actually inserts itself below your main Windows installation. Your everyday Windows desktop becomes what's called the parent partition. It's technically running as a privileged virtual machine itself, sitting right next to any other VMs you create, both managed by the hypervisor underneath. This is the same category of technology used by VMware, ESXi, and the hypervisors that run in data centers. WSL2 is the odd one out. It's not trying to virtualize a full desktop operating system. Under the hood, WSL2 actually does run a real lightweight Linux kernel inside a minimal Hyper-V-based virtual machine, but Microsoft built an entire management layer on top that makes it feel like Linux is just there. Your files, your terminal, your network, integrated directly into Windows. No VM window, no separate desktop to manage. It's optimized for one job, running Linux tools and Linux command line environments as fast and seamlessly as possible. That architectural difference is the reason WSL2 starts in about a second, while a Hyper-V or VirtualBox virtual machine has to go through an actual boot sequence, BIOS or UEFI screen, bootloader, kernel init, the whole thing, every single time. Performance, where each one actually wins let's talk performance, because this is where most people make their decision, and it's also where most online advice is outdated or just wrong. CPU performance, because Hyper-V and WSL2 both use hardware-assisted virtualization extensions built into modern Intel and AMD chips. CPU-bound workloads run close to native speed on both. VirtualBox also supports hardware acceleration, but its additional emulation layer for things like the virtual chipset and device drivers adds a small but measurable overhead, especially on CPU-intensive builds or compilation tasks. If you're compiling large code bases, running containers, or doing anything CPU-heavy, WSL2 and Hyper-V VMs will consistently outperform an equivalent VirtualBox VM by a noticeable margin. Disk I/O is the one that surprises people. WSL2's file system performance is excellent, as long as you keep your project files inside the Linux file system rather than accessing them through the Windows-mounted drives at /mnt/c. Cross-boundary file access between Windows and WSL2's Linux side used to be painfully slow. And while Microsoft has improved this significantly, it's still meaningfully faster to keep your working directory natively inside WSL2's ext4 volume. Hyper-V and VirtualBox VMs, by contrast, use their own dedicated virtual disks. So this isn't a factor, but you pay for that with slower VM startup and larger disk footprints, since you're maintaining an entire separate operating system image rather than a shared lightweight kernel. Memory overhead is where the differences get real. VirtualBox and Hyper-V both require you to pre-allocate or dynamically manage a chunk of RAM specifically dedicated to each virtual machine, and that memory is largely locked away from the rest of your system while the VM runs. WSL2 has historically been criticized for over-allocating memory and not releasing it back to Windows promptly, though this has improved with configuration options that cap and release memory more aggressively. If you're running WSL2, this is worth knowing. You can create a .wsl config file in your Windows user folder to explicitly cap how much RAM and how many CPU cores it's allowed to use. Without that file, WSL2 defaults to some fairly generous limits that can eat into what your other applications need. Use case 1. You're a developer who wants a Linux shell. This is the single most common reason people land on this comparison, so let's start here directly. If your goal is, I want to write and run code using Linux tools, but I still want to use Windows as my daily driver, WSL2 is built specifically for you, and it's not close. You get a real Linux kernel, real Linux package managers, real Linux command line tools, apt system services in newer versions, native Docker integration, all while your file explorer, your browser, your Windows apps keep working exactly as they always have. VS Code's remote WSL extension lets you open a project that physically lives inside the Linux file system and edit it as if it were a completely normal local folder, with full IntelliSense and debugging support. It's also worth mentioning that Docker Desktop for Windows uses WSL2 as its backend engine now. So, if you're already running Docker containers on Windows, you are, whether you realized it or not, already relying on WSL2 under the hood. The trade-off: WSL2 is Linux only. You cannot use it to run Windows guest VMs, Mac OS, BSD, or anything other than a Linux distribution. If your workflow needs anything beyond a Linux environment, you're in the wrong tool. Use case 2. You need a full, isolated operating system. Now let's say your need is different. You want to boot a completely separate operating system. Could be another Windows version for testing, a Linux desktop environment with a full GUI, even certain BSD variants. You need something that behaves like an actual computer, with its own boot process, its own desktop, isolated from your host in a way that a shared kernel tool like WSL2 simply isn't designed for. This is Hyper-V and VirtualBox territory. And now the decision comes down to which of those two fits you. First filter. Hyper-V is not available on Windows Home Edition at all. It ships only with Windows Pro, Enterprise, and Education. If you're on Home Edition, that decision is already made for you. VirtualBox is your only option here, and honestly, it's a genuinely capable one, not a consolation prize. If you do have Pro or above, here's the trade-off that catches people off guard. Enabling Hyper-V changes how your entire system runs. Because, remember that architecture diagram from earlier, turning it on effectively puts a hypervisor underneath your whole Windows installation, all the time, whether or not you currently have a VM running. This has historically caused compatibility conflicts with other virtualization software, most notably older versions of VirtualBox and certain emulators, because they can't both claim the same low-level virtualization hardware access simultaneously. Recent versions of VirtualBox have largely resolved this by adding support for running alongside Hyper-V. But if you're troubleshooting a weird performance issue, or a VM that won't start. Is Hyper-V fighting with my other virtualization tool? Is one of the first things to check. VirtualBox's advantage in this full OS use case is flexibility and portability. It runs on Windows, Mac OS, and Linux, so if you ever switch host operating systems, your skills transfer directly. Its snapshot system is mature and easy to use through the GUI. You can take a snapshot before making a risky change and roll back with 2 clicks if it goes wrong. It also has a large ecosystem of pre-built virtual appliances you can import directly. Hyper-V's advantage is that because it's the same hypervisor technology used by Windows Server and Azure, it tends to deliver better raw performance for full VMS, and it integrates more tightly with Windows features like Windows Sandbox, container isolation, and enterprise management tools. If you're in a corporate environment where IT policy already assumes Hyper-V, that's usually the path of least resistance too. GPU, pass-through, and hardware access. This is a section a lot of comparison videos skip entirely, and it matters a lot if you're doing anything GPU related, machine learning workloads, GPU accelerated video encoding, or just wanting smoother graphics inside a VM. WSL2 actually has genuinely good GPU support for compute workloads. Microsoft built in GPU pass-through support that lets Linux applications running inside WSL2 access your GPU directly for things like CUDA-based machine learning tasks without needing any complex driver configuration inside the Linux environment. It uses your existing Windows GPU driver.
Hyper-V supports something called GPU partitioning, sometimes called GPU-P, which lets you share a slice of your physical GPU with a virtual machine. It works, but it's considerably more involved to configure correctly, and support can vary depending on your specific GPU model and driver version. VirtualBox is the weakest of the three here. It offers basic 3D acceleration through its own graphics emulation layer, which is fine for a smoother desktop experience inside the guest, but it does not offer real GPU compute pass-through. If you need a VM to actually use your graphics card for serious processing work, VirtualBox is not the tool for that job. So if GPU access matters to your use case, that alone can be the deciding factor, independent of everything else in this video. Networking and file sharing. Networking configuration is another area where these three diverge quite a bit, and it affects how easily you can, for example, access a web server running inside your VM from your regular browser, or let devices on your local network reach it. VirtualBox gives you the most granular, GUI-driven control. NAT mode for simple internet access. Bridged mode to put the VM directly on your local network with its own IP address. Host-only mode for an isolated internal network. And you can mix and match per virtual network adapter. It's the most beginner-friendly to configure because every option is a drop-down menu. Hyper-V uses a concept called virtual switches, which are more powerful once you understand them: external, internal, and private switch types. But the configuration process is less visual and more likely to require digging into PowerShell if you want something beyond the defaults. WSL2's networking has actually had one of the bumpier histories of the three. For a long time, WSL2 ran on its own virtual network with its own IP address, which caused real headaches for anyone trying to access a WSL2 hosted service from another device on their network, or run a VPN on the Windows host while using WSL2. Microsoft has since introduced a mirrored networking mode that makes WSL2 share the host's network interface directly, largely solving that problem. But depending on which Windows and WSL version you're running, you may or may not have that available. So it's worth checking your version if networking issues come up. For file sharing between host and guest, WSL2 gives you direct, fast, built-in access to your Linux files from Windows Explorer through a special network path, and access to your Windows files from inside Linux through the mounted drives we mentioned earlier. VirtualBox requires you to manually configure shared folders through its settings, plus install what's called the guest additions inside the VM for full functionality. Hyper-V has a similar enhanced session mode and guest services feature for file sharing, but again, configuration tends to lean more toward PowerShell than a simple checkbox. Ease of setup and daily usability. Let's talk about what it actually takes to get each one running, because setup friction is a real factor in which one you'll actually stick with. WSL2 is, without argument, the easiest to get started with. A single command, WSL-install, handles enabling the required Windows features, downloading a default Linux distribution, and setting everything up. Within a few minutes and one restart, you have a working Linux terminal. VirtualBox requires downloading and installing the application itself, then downloading an ISO image of whatever operating system you want to run, then walking through a VM creation wizard where you set memory, disk size, and virtual hardware options, then actually installing the guest OS from that ISO. The same install process you'd go through on real hardware. It's more steps, but every step is visual and well documented, which makes it approachable even for people newer to virtualization. Hyper-V setup starts with enabling the feature through Windows Features or a PowerShell command and a restart, and from there you're either using Hyper-V Manager's GUI to create VMs, which is reasonably clear once you're in it, or PowerShell for more advanced configuration. The interface feels less consumer-oriented than VirtualBox's, more like an admin tool because that's genuinely its lineage. One more usability point worth flagging. If you rely on snapshots, saving a VM's exact state so you can revert later, VirtualBox and Hyper-V both handle this natively and well. WSL2 doesn't have a built-in equivalent. The closest option is exporting your entire distribution as a tarball and re-importing it, which is far clunkier than a one-click snapshot. If you need a full separate operating system, you're on Windows Pro or above, and raw performance or enterprise-grade features matter to you, Hyper-V is generally the stronger choice, with the caveat that its always-on hypervisor architecture can occasionally conflict with other virtualization tools. If GPU compute access is a hard requirement and you're working within Linux, WSL2's CUDA and DirectML support makes it the clear pick over the other two. And here's something worth explicitly saying. This doesn't have to be an exclusive choice. It's genuinely common, and often the right setup to run WSL2 for your day-to-day development work, while also keeping a Hyper-V or VirtualBox VM around specifically for testing a full separate operating system when the need comes up. They're not mutually exclusive tools competing for the same job. They're solving different problems that happen to get lumped into the same search results. Common pitfalls and quick tips. A few practical tips before we wrap up, things that would have saved me time if someone had told me up front. 1. If WSL2 is eating more memory than expected, create that .wsl config file in your Windows user profile folder and set explicit memory and processor limits. 2. If you're switching between VirtualBox and Hyper-V and getting strange errors about virtualization not being available, check whether Hyper-V is enabled in Windows features. Recent VirtualBox versions handle coexistence, but it's still the first thing to check when a VM refuses to start. 3. For WSL2, always keep your active project files inside the Linux file system rather than under /mnt/c unless you have a specific reason not to. That single habit fixes most WSL2 performance complaints you'll read online. 4. Check whether your Windows and WSL version supports mirrored networking mode if you're having trouble accessing WSL. 2 services from other devices on your network. It's a setting worth turning on if it's available to you. So, WSL2 for lightweight, fast, Linux command line integration. VirtualBox for accessible, cross-platform, full OS virtualization, especially if you're on Windows Home. Hyper-V for performance-focused, full OS virtualization when you're already on Windows Pro or above. None of them is objectively the best. They're built for different jobs, and now you know which job is yours. If you found this useful, there's a follow-up video on setting up a hardened, isolated VM sandbox for privacy-focused browsing. Links on screen now. Thanks for watching.